Okay, party people, so we're going to talk about the graphs of secant and cosecant, and I'm just going to jump right into this video. Okay, so I have a ton of points I'm going to graph to just show you like what the sketch of these look like, because I'm not going to lie, they're a little wacky. So let's just go ahead and like digest the inputs here. So for one thing, secant x is equal to 1 over cosine of x. So whenever I plug in these points, so for instance, if I plug in secant of negative pi over 2, that's the same as cosine of negative pi over 2. And so that's just going to be undefined because cosine of negative pi over 2 is going to be 0. So, okay, so we should know some of these points by now. So what about secant of negative pi over 4? Well, that's the same as cosine of negative pi over 4. So when you figure this out, when you go through the work to figure this out, so for negative pi over 4, so remember, here would be negative pi over 4, and I need to take the x coordinates, so this would be square root of 2 over 2. So I just kind of want to show you, like, I guess, like, how much more complicated this gets with secant and cosecant. I want you just to appreciate it. I'm going to show you some tricks for this later, so just go with me here, okay? So, all right, so I've got 1 divided by square root of 2 over 2, because that's what the value of cosine of negative pi over 4 is. So here's, like, the math that we need to do. And then it's like I have to divide 1 divided by that, and then I have to rationalize, and all of this to say that when I plug in negative pi over 4, I get 2, and you can see all my work here. So you can pause and read that if you want to. So I continue down the list. I plug in 0. So if I plug in 0, that'll just give me 1 because it's 1 over 1. If I do secant of pi over 4, for similar reasoning to negative pi over 4 is also square root of 2. And then for secant of pi over 2, this will come out to undefined because cosine of pi over 2 is 0. So I have 1 divided by 0, so that's undefined. So this looks nothing like sine and cosine and tangent and cotangent, right? Like we have these kind of wacky coordinates, but like I said, just go with me here. If I continue this, so plugging this in, I'll get negative square root of 2. And then if I plug in pi, I get negative 1, and then I come back here and I'll get back to something that's undefined. So I have like all these points here. All right, so let's just graph it, all right? So first things first, let's set up our axes. So I have gone ahead and marked square root of 2 just to help me figure out where to graph these things. So I've got 1 and 2 on my y-axis. Here's where square root of 2 is. And then you can see what I did for my x-axis. All right, so anywhere it says undefined, you guys know that means an asymptote now. So I'm going to go ahead and mark those. And then I can plot all these points. So I have all these points. And this just looks kind of weird, right? So I got boop, 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 boop. Okay, so I got all those points there. Yeah, it looks odd. So I'll just show you what the graph looks like. It looks like this. So it's a little wacky, you know? And if I wanted to continue this, so I could continue the pattern here. So up, down. So I could continue with my asymptotes, continue that pattern, and then I could continue this pattern. So this goes down, this goes up. So we go up, down, and you got your boop, 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 boop. Okay, so all my points. So I can continue the pattern with that. Here's like the whole graph of secant of x. It's a weird one. All right, so hold that thought. I'm going to show you some other things about this, but I want to pivot and talk about cosecant of x. I've got another just long list of points here that I want to kind of just chug through real quickly. So plugging them in. So remember, cosecant of x is the same as 1 over sine of x. So if I start with cosecant of 0, that'll be 1 over sine of 0, so that's going to be undefined. If I go with cosecant of pi over 6, that'll be 1 over sine of pi over 6. And again, so sine of pi over 6, that's 1/2. So then you've got to just kind of do your magic, and this will work out to being just 2. If I did cosecant of pi over 3, that's 1 over sine of pi over 3. So just as a quick reminder, so sine of pi over 3, that equals square root of 3 over 2. And so then I could do all the work there to figure that out. And I would ultimately get 2 square root of 3 over 3 as I'm working this out. So again, you can see these like kind of crazy looking points, you know? And I can continue on. I just chose some random points to plug in here. So if I plug in pi over 2, I'll get 1. If I plug in 2 pi over 3, I'm going to get, again, that 2 square root of 3 over 3. If I plug in pi, I get something undefined again. If I plug in 3 pi over 2, so just so on and so forth. So I've got all my points here. So I've just grabbed these like random points to get you a sense of what the graph looks like. So we will graph it. So first of all, since I'm going from 0 to 2 pi, and I have quite a few points I need to graph here, I'm actually going to shift my axes. So I'm going to shift my axes like this. And all right, so now I can mark up my axes as you see here. So I'm going by pi over 3s. And then I can start with these undefined values. So you know what to do with those. Those are all asymptotes. So we can go ahead and mark those. And then, oops, I forgot to do my y values. Or my y values, my bad. Okay, so now I can go ahead and start like plotting these points, right? So I've got my pi over 6, my pi over 3, pi over 2, and then I have this other random point over here. It looks very similar to secant. So very, very similar, right? It's just kind of shifted over. But again, it's kind of a wacky looking graph. Okay, so lots of stuff to talk about with this. I'm going to show you a much easier way to graph this because you can see in how we've graphed these last two. I'll just say it, it kind of sucks, you know, it kind of sucks. So I have a trick I'm going to show you in a few minutes. But let's talk about just these graphs in general before I show you that trick. And oh, here, if I wanted to extend it, it could look like that. Okay, so let's talk about the period of these graphs. These graphs do have a period. So notice how it's repeating. So up, down, up, down. That is that period that we're looking for. So secant definitely has a period, as does cosecant. So it's down, up, down, up. This repeats itself. So this definitely has a period. And the period for both graphs is 2 pi. Now, there's a few other things I want to say about this. With period, you want to treat the period the same as sine and cosine, and you will see why you couldn't do that in a few minutes. So when you're thinking about the period, you can literally think of it the same way. So if I have a secant bx or a cosecant bx, I find period that same formula that I did for sine and cosine, 2 pi over b, and then you can still divide by 4 to figure out like the steps that you want to use. Again, I'm going to show you how that all comes together in a few. And also, when we're dealing with period, I might as well just mention it here. If you have some like translations, vertical or horizontal translations, you can use this formula, this 3-part inequality, to figure out where to start your period. And so that's the exact same, right, as when we were working with sine and cosine. So it's somewhat familiar to us. So we can kind of recycle some stuff for these crazy looking functions. Okay, so continuity, the graphs are continuous everywhere except where they have asymptotes. Now, you know that they have a lot of asymptotes. You can see for both of them that they have all these asymptotes. They just go on for forever. So you might remember from tangent and cotangent, we had a certain form for where we had discontinuities. So secant is discontinuous when x is an odd number, 2n plus 1 times pi over 2. And cosecant is discontinuous when x equals n times pi. So n can be any integer that you want. So it's either an odd number times pi over 2 or n times pi. Okay, so from those, that inspires what our domain is. So I've just got those listed here just to point them out. There's that connection between continuity and the domain. And then the range for both. So if you look at these, these are kind of interesting. All of these bottom out at 1. There's this blank space here. And then we have -1 and all the way down. So how do we translate that into a range? Well, it's -infinity up to -1. And then we make that jump. Oops, this should be to positive. Sorry, my bad. That should be to +1 to infinity. So this is how we make that jump from -1 up to 1 for both graphs. And then they just continue on for forever. Now, notice neither one of these graphs have any x-intercepts, right? They never cross the x-axis. It doesn't do it, so no x-intercepts, so that's kind of cool. And then just to mention symmetry, because I've talked about it in some of my other videos, secant is even, cosecant is odd. Neither graph has amplitude because they do not have minimum or maximum values. And okay, so now let's talk about graphing. I know these look like a nightmare to graph, but actually we can sneakily use the sine and cosine functions as a guide to graph. I'm going to show you how to do that in the next example. So first of all, let me show you what I mean by like we can sneakily use these. So here's my graph of secant x. Okay, so so in gold now, you can see I've like overlaid these gold points here. So these are the points of the graph of cosine. So those are points from cosine. And so check it out. It's cosine in disguise. So this is what we mean by using sine and cosine as a guide, because notice like where these peaks and valleys are on cosine, that's actually where these curves like have their tops or their bottoms. So this is how we can kind of leverage those. So actually what you've already learned about sine and cosine, you get to leverage it all here to make the graph so much easier versus having to come up with these like cajillion points. Cosecant, I'll show you that one more time. So if I were to just go ahead and graph the points of sine, and then if I were to connect them, boom, there's sine. So we can see this like visual connection now between sine and cosine. Okay, so I would recommend, so that you don't forget this, because this is like a lot that I'm telling you here, I would recommend that you go back and you just make a little sketch of how these work so that your brain kind of processes how to put this all together. Okay, so a couple other keys for graphing I want to tell you about. Okay, so those guides that you want to use, so if you have cosecant, a times cosecant of bx, you can use a sine of bx. Okay, not surprising, right? There's that connection between cosecant and sine. And then for a secant bx, you can use a cosine of bx. Again, not surprising, there's a connection between those two functions. I'm going to totally show you how to use that in a few minutes. The other thing I want to tell you is that you can find the asymptotes for your secant and cosecant functions by using the x-intercepts from the guide function. Again, I'm going to show you what that means. Okay, so let's do it now. So I've got 2 cosecant 1/2 x. So the guide function, remember there's that connection between cosecant and sine. So I'm going to just graph sine. 2 sine 1/2 x. So I'm going to go through all the work to graph this. I'm not going to worry about this for right now. So I'm just going to go through all the work to graph this. So this is what we're going to graph first. The period for this function is found by taking 2 pi divided by 1/2. So it's going to equal 4 pi. That means that the steps that I make as I'm coming up with my table, I'm going to make 4 pi divided by 4. So my steps are going to be pi width. And then I'll just note here that this has an amplitude of 2. Now I have no horizontal or vertical translations, so I know that this graph can just start at 0. So we've talked about that a lot in other videos. So you definitely want to be good with sine and cosine before you start this. Alrighty, so start it at 0, start with the point 0, 0, and then I can just go ahead and make those pi steps. So add pi, 2 pi, 3 pi, 4 pi, I've made all my proper steps, and you know what to do here. So now we just need to figure out the y values. So, okay, let's go ahead and do this. So I can plug in pi. So if I plug that in, so sine of pi over 2 is going to give me 1. And then remember, you have to multiply that by 2. So I get the value of 2 here. If I plug in 2 pi, so sine of pi is just going to be 0. So this whole thing will equal 0. And then I have just filled in the rest of the table here. So I think you guys know how to do the math, and I'm trying to keep this video a little shorter. So these would be the rest of the values from this function. Okay, so this really is a guide to help us graph. So what we're going to do next is I'm going to take these points and I'm going to just remind myself. So I've done this in a different color so I don't forget that this is the guide. And now I'm going to set this up for this function. So I need to set up my graph. So I've set up my axes like so. So I'm going in intervals of pi. Here's 1 and 2 on my y-axis. So I've got everything set up here all hunky-dory. And so now I'm just going to go through and I'm just going to graph my function sine. So I'm going to plot all these points. So, you know, all there. And now I want to be careful with how I actually graph this. So I don't want to use a solid line. I want to make sure I'm remembering that this is a guide. So notice that I just make this like lighter dotted line because this is my guide. Okay, believe it or not, we are almost done. Okay, so the next thing to know, and I told you this earlier, the x-intercepts stand as asymptotes. So where are the x-intercepts on my dotted line? They are here, here, and here, right? So those are the 3 x-intercepts. That is where you're going to mark your asymptotes. So check it out. Boop, boop, bop. Okay, so we're actually there. we're like basically done. Once you have those intercepts set, now you know what the rest of this pattern is. So the graph that's up here, This is going to be the top of the, where one of those like little humps bottoms out. And then this will be one of the other parts of the graph. So what I mean is, now I draw my graph so that it goes through this point and through this point, and boom, you're done. So really, you just have to know how to graph sine or cosine and use those guides. And then once you have that drawn, you can figure out the rest of the graph. So now let's take a look at something a little crazier. So I have something with a translation, and I've talked a bunch about translations in this series, and I just wanted to go through one. So I think just by looking at this, you probably already know some of the translations happening. As far as what the guide function is, it's literally taking this, except switching out secant for cosine. And okay, so we're gonna go through all the work to graph this. So what I want to recommend here actually is, I think that you should try to graph this. And I will give you a hint, and I'll tell you that this one, when it moves the function up, this will move up the line that you use to mark your asymptotes. If that doesn't make sense, that's okay. What I would recommend though is that you at least try to graph this as far as you possibly can, and then when you're stuck, hit play. Okay, so first things first, we've got to determine our period. So I don't have anything next to the x, and my period is just 2 pi, which means that my steps are going to be pi over 2 in width. Amplitude in this case is 1/2, and then this graph is going to move up pi over 2 units to the right. So it's going to move up 1, and then it's going to move pi over 2 units to the right. Now, I'm going to repeat this again. This moving one up, this is going to move our asymptote cutoff line off. I will show you what I mean by that in a few minutes. Just keep that in mind. Okay, so now that I see that I have a horizontal translation, so remember with sine and cosine, when that happened, then we had to figure out what's the new starting point. So we use this 3-part inequality. So I can go through the motions to figure that out. So my starting point is going to be here at pi over 2. So I can go through now everything for my guide function starting at pi over 2. So remember, my steps are pi over 2 in size, pi over 2 steps. Okay, so I can go ahead and figure those out. So add pi over 2 to that, I get pi, 3 pi over 2, 2 pi over 2, 5 pi over 2. There's everything that goes into my table. And so from here, now you just have to figure out your y coordinates. So again, if you haven't done that, I would recommend you pause the video and figure that out. So if I go through and do this, so I'm just going to very quickly show you the work that goes into this. So if I plug in pi over 2, here's what I'll get. And so this will come out to just 1 plus 1/2, so it's going to be 3/2. And then if I plug in pi, so I've got all my work here, so this comes out to 1 times 1/2 plus, this should be cosine, sorry, this should be cosine. Sorry about that, just fix that. Okay, so I end up with cosine of pi over 2. Cosine of pi over 2 is just 0, so this just becomes 1. Then I can plug in, let's see, if I continue on with this, 3 pi over 2, so that'll come out to 1/2. You can see my work here. I'll continue down the line. 2 pi, this will end up being 1, and then 5 pi over 2, so very similar work to what we had here before. So here's the table that I'm going to use as my guide. So I'm going to graph everything here. So I have to set up my axes once again. So here are my axes. So I've got my y's going from 1 to 2, and then you can see what I've set up my x coordinates as. So I've got everything I need to do this now. So I can go ahead and plot all these points. So there we go. There are all my points. And then I can go ahead and I can graph. And remember, I want to use a dotted line to do this. Okay, so now this is what I was talking about at the beginning of this, of moving the asymptote line up 1. So you might notice that when I'm trying to figure out what are the asymptotes of this, so I'm supposed to use the x-intercepts. The problem is, because this function moved up 1, I no longer have x-intercepts with it, right? So that's the issue. So this is what I mean when whatever amount your function moves up or down by, you want to move that asymptote cutoff line, you want to move it by that. So if this were to move up 5, you'd move this line here, you'd move it up 5. If this were to move down 7, you'd move this line here down 7. So you see this dotted pink line I have? So I'm kind of like changing where that cutoff is for asymptotes. And so what that means then is that these are the points where I'm going to have my asymptotes now. So that's how you have to tweak that if you have a translation. anyways, so now that I see how to treat that, so I can go ahead and just mark where my asymptotes are going to be. And now I'm good to go. So here's going to be the bottom of, you know, one of my functions, part of my function. Here's the top, here's the bottom. So I know how this all goes. So now I can just go ahead and use all these guidelines to finish drawing this. Whew. And so that's it. It's a little bit different. I think it's nice to know that you have sine and cosine because you're pretty familiar with those. So that's it for this video, guys. Hopefully that was helpful, and I'll see you guys in another video. I will post some extra examples to go along with this.